students, welcome back. In the last class, we discussed the factors affecting the rate of SN1 reaction. In that part 1, we discussed the effect of alkyl group, how it will influence the rate of reaction. So we discussed and concluded that the tertiary alkyl will go a faster SN1 reaction because it forms stable carbocation. So stable carbocation gives the fastest SN1 reaction. Among the alkyl halides, methyl, primary, secondary and tertiary, the tertiary alkyl halide will give a tertiary carbocation which is most stable. That's why it will give a fastest SN1 reaction. Also we learned the carbocation is stability is depend on hyperconjugation. And later we discussed one more thing, that is the rearrangement of carbocation. As a result, we will get the rearrangement product. So these are the summary of the effect of alkyl group in SN1 reaction. In this class, we discuss the effect of a leaving group. Now, how the leaving group will influence the rate of reaction. So generally what the students will think is, in the effect of alkyl group, the tertiary is fastest. So similarly we will get for SN1 we will get opposite. So this is for SN1, okay, this is for SN1. But in the SN2 I am talking about effect of alkyl group. So in the SN2 we get like this. We get like this. So this is for the effect of alkyl group for SN1 and SN2. You see here both are reverse. So the students assume that, okay, that means the effect of leaving group will also be a similar way. That means it will be reverse. For the SN2 reaction we studied the iodine is a good leaving group, then bromine, then chlorine, then fluorine. That means this is a good and this is the worst. So the students assume that, so that means for the SN1 it should be reverse. No, it's not the case. Please recall the SN1 general reaction and its mechanism. The first step is the cleavage of the halogen. Unless the halogen don't depart, that it won't form a carbocation, then the nucleophile will attack. The first step is a mandatory. That means the halogen have to leave fast. As we know, the carbon iodine is the weakest bond. The carbon fluorine is the strongest bond because it is the shortest. That we already discussed. That means the same order will be for SN1 also. Okay. That means the iodine is a good leaving group, then bromine, then chlorine and fluorine. The effect of leaving group will remain same for SN2 and SN1 because it is a mandatory. The leaving group have to depart, then only it will form a carbocation. So why the order will remain same. Okay. So these are about the effect of leaving group. Next, we are going to see the third factor, the effect of nucleophile. So please remember that, again you have to recall in the rate determining step, the general reaction of SN1 mechanism, the nucleophile is not at all involved in the rate limiting step. That means the nucleophile is not going to play any role in the rate of reaction. Neither it will increase or decrease the rate of reaction. Okay. But however, there is certain key point that we will enter. First, we will see some example. So this is the tertiary alkyl halide. This is the tertiary alkyl halide, and in the presence of water, and this is the calcium formate. The first step is the formation of carbocation. This is the carbocation is formed, and next the water, and this is the formate ion, and these are the nucleophile, and it gives the corresponding product. You see, the water is reacting with this carbocation and it forms alcohol as a product, and this formate ion is trying to attack this carbocation and form this. This is the tertiary butyl formate. So these are the product. You see, here the product distribution may vary, but it won't involve in the rate of reaction. Please remember that there is a big difference. Okay, the strength of the nucleophile is not going to influence the rate of reaction, or influence the rate of the reaction means it neither way decrease or nor increase. But if we are having two different nucleophiles, according to the strength and the concentration, the product distribution will vary. Some of the product, the substitution product, may form in excess amount, or some will be in the lower amount, based on the strength and the concentration of the nucleophile. Please remember that the strength of the nucleophile is not at all involved in the rate of reaction, but the product distribution will vary. Okay, so for this is the example. So these are about the nucleophile, and last one is the effect of solvent. The effect of solvent. So we already discussed the purpose of the solvent and the types of solvent. In the SN2, so we use polar aprotic, but for the SN1 we should choose polar protic solvent. Okay. For example, polar protic solvent, so you can use water as a polar protic because it's having proton, like any alcohol. So these are the polar protic solvent. Why polar protic solvent are favored for SN1 reaction? The reason is after forming a carbocation, suppose this is a tertiary carbocation, this is highly charged species, and it may be stabilized by the lone pair of electron by like this. So it will form a stability by this, the lone pair electron. It will minimize the energy, so this carbocation may get stabilized. And another reason is, so the counter ion, for example the halide, suppose if it is a bromide ion, so in the first step it forms a halide ion and the carbocation. This halide ion may be easily solvated by like this, like this, like this. So it will try to solvate. Thus the polar protic solvent can easily solvate this counter anion. So why we prefer the polar protic solvent for SN1 reaction. These are all about the factors affecting the SN1 reaction. See you.